All right, we got 3 questions to get through today, and what we want to do is we want to take vectors and apply them to real-world situations. Because you guys always want to know when are we going to use this in real life, right? So I'm going to give you 3 classic examples of how you can use this in real life. All right? We're going to start with a truck. Truck weighing 4,000 pounds. It's a truck. It's a truck. Or an elephant. Yeah, Ishka's gone, and she wants to be Emma, and nope. Group hug. All right, here we go. So a truck weighing 4,000 pounds parked at a driveway, inclined 30 degrees to the horizontal. So 4,000 pounds. Can you handle that? Ton is 2,000 pounds. So this is 2 tons. Very good. You guys are excellent in mathematics. All right, so we got a 30-degree incline. You all good with that? Could draw my truck. Sam, I'm going to kick you out of class. You need to shut up. All right, here we go. I'll be on YouTube. We'll just delete this video. Okay, here we go. We got the truck, and what we need to do is we need to make some sense out of this because it's talking about a force against the driveway. It's talking about a force required to keep it from rolling down the driveway. And then it's talking about the 4,000 pounds of force. If your weight, that 4,000 pounds or 4,000 pounds of truck, how do we measure weight? I mean, how does it, yeah, it's about gravity, right? Pulled towards where? The center of the earth. So if we're headed towards the center of the earth, everybody agree that we're going to go straight down to the horizontal? Very good. So this is the first piece we need, okay? Straight down to the horizontal, we have 4,000. And the fact is this is gonna help us make a smaller triangle that is composed of this truck. All right, that's the gravity, 4,000 pounds straight down. But we also have a force that is required to keep the truck from rolling down the driveway. And then we have another triangle, or another side, the force that's exerted against the driveway itself. And so there we have this triangle. It's a truck triangle. Very good. You are smart. Everybody okay with that? I've got a triangle. A represents the force required to keep it from rolling back down. B represents the force against the driveway. I need an angle. Somebody see an angle within the small triangle other than 90 degrees. Where? Yep. Parent sees 60 degrees right here. Everybody see 60 as well? 30, 60, 90. So you got the big triangle, 30, 60, 90, and that's going to compose a smaller triangle, 30, 60, 90 with a shared angle as well. Parth is a genius. We all knew it. All right, so I'm going to flip this triangle because that's what I do. I flip things. So I got 4,000, I've got 60, and I've got A, and I've got B. Can somebody here, anybody, give me a trigonometric function that relates A, 60, and 4,000? Cosine. The cosine of 60 degrees is equal to A over 4,000. How do I solve for A? Yeah, 4,000 times the cosine of 60 degrees is equal to A. Everybody here knows that the cosine of 60 is 1/2. And 1/2 times 4,000 is 2,000. So A is equal to 2,000. How do we find B? Pythagorean theorem or which trig function? Sine. So sine of 60 degrees is equal to B divided by 4,000. So simply take 4,000 times the sine of B. $3,464. Y'all good with that? So, magnitude force required to prevent the car from rolling down the driveway, that would be A, 2,000 pounds. And the magnitude force experienced by the driveway due to the weight of the car, 3,464 pounds. Okay, time for a little experiment. All right, well, let's look at this next one. How is this next one different than the first one? Okay, it's a lawnmower. It's being pushed. What else? What are we trying to compute in this one? The work being done. So I want to compute the work being done. Don't know what happened to my. There it is. I've got a hole in my pocket. So every time I put something in my pocket, it just eventually just makes its way to the ground. So it should go past my marker. All right, there we go. Yep. So a lawnmower is being pushed. All right, so we need to draw a picture here. Let's go. What? We're gonna go like this. Yeah. Yeah, I got to do that. Very good. YouTube, we're having a lot of conversations right now about mowing the lawn, so it'll be a little while before we got to do that yet. So, yeah, yep, definitely some long grass. Yep, that's why I'm mowing it, Sam. Yep, he's a one-handed lawnmower mower. He's waving to his friends. He's doing some mathematics, calculating the work he's doing. Yep. All right. So, can somebody here tell me how do I calculate work? Force times distance. Great. Well, we said that you just got to write a force vector and a distance vector. So let's do the easy one first. I think the distance vector is going to be super easy. What's our distance? 80. But this is vectors have horizontal and vertical components. So what's the horizontal component of the vector? What's the vertical component? Oh, so 80, 0. That was easy. Stop raining on our parade, Noah. Noah brings up a really good point here. So there's no way that everybody's yard is flat. So if you were to change this to say that there's some inclines and declines along the way, then all of a sudden it changes a lot in terms of your work. Okay. All right. So here we go. Well, now I got to come up with the force vector, and I know that there are 60 pounds of force being applied to the handle, and I know that we have 35-degree angle right here. Can somebody see a triangle that would be formed? All right. If your drawing is not accurate, please erase and start over. Very nice lawnmower, Ishika. You should major in drawing lawnmowers. All right. So I have component B and I have component A. I have a horizontal component to my vector. I have a vertical component to my vector. Can somebody tell me what I use to find out A? Cosine. Now, you guys are kind of wondering. Think about this, folks, okay? X and Y in the unit circle. X and Y in the unit circle. Is cosine X or is cosine Y? Cosine is X, the horizontal. Sine is Y, so the vertical. So vertical. So therefore, what we have is A is equal to 60 times the cosine of 35 degrees. So you just end up multiplying the 60 over, right? And then B is equal to 60 times the sine of 35 degrees. And that will give us the components of that vector. Turn it on. Calculator. 60 cosine of 35 and 60 sine 35. 49.15. 34.41. Can you multiply two vectors together? Do you remember how to do that? How? Yep, multiply the x values, multiply the y values. So 49.15 multiplied by 80, and I get 3,932. Plus what? 0. So 3,932. And our label is the force is in pounds, the distance is in feet. So we call it foot-pounds. Not feet per pound, but foot-pounds, because you're multiplying the two together. What do you think of that? And one more. Yeah, think about that when you push your lawnmower around. You're going to back up previous page to example number 9. What? You got a snapper lawnmower? And what's so cool about it? Oh, no brakes. Okay. Okay. All right. Wait, oh, so you're riding lawnmower. Oh, wow. Good for you. Is that how you learned how to drive? Okay, serious crafts. All right. Anybody ever flown before? Did you ever encounter any wind? Kind of frustrating when you feel that, right? Suppose that a plane is traveling at 600 miles an hour, but there's a tailwind. That tailwind is going to make it actually go faster, isn't it? Yeah. See, it's your speed is measured relative to the wind. So, for example, anybody have you ever gone on one of those like walking escalators at the airport? Yeah. So if I'm walking on the escalator, I could walk at say 3 miles per hour. But if the escalator is also moving at 2 miles an hour, then relative to the earth, I'm moving at 5 miles an hour, right? But relative to the escalator, I'm moving at 3 miles an hour, right? You see that? So the wind is kind of like that escalator, and the plane is like us. And so these forces are going to act on each other. And so we're going to try to calculate this plane that's flying at north 80 degrees east with a speed of 450 miles an hour, and then the wind blowing at north 20 degrees east at a speed of 60 miles an hour. How is that going to affect the overall angle at which the plane is traveling? And also, how is it going to affect its overall speed? Sounds super complicated, doesn't it? We're going to make it super easy. Are you ready? Here you go. Gonna grab my super duper line maker here. And can somebody point in the direction that the plane is heading? North 80 degrees east. Like up here on the board. Okay, I see a lot of people pointing in this direction, so where do I go from here? Okay, so I'm going to label this as 450 because that is the force of the plane traveling. You sure can. You're using some open space, right? Because this isn't the actual problem we're doing, right? You know that, right? You would have to flip back. Okay. All right. So if this is 80 degrees, then what is this angle? 10 degrees. Hey, it looks like the plane has a horizontal and vertical component to it, doesn't it? So let's take the speed of this plane and put it into vector form. How would I come up with A? A is equal to 450 times the cosine of 10 degrees. How do I figure out B? 450 times the sine of 10 degrees. She takes after you, Sam. $443.16. And I'll do it again. 450 sine of 10 degrees. And I get 7814. Okay, there we have that. And so I'm going to take that and I'm going to put it on my paper where I have room here. It says to express the velocity of the jet as a vector in component form. So instead of just simply saying 450 miles an hour, I'm going to write it as a vector. And can you guys tell me what that vector was? 443? Then what? 8.1. We're so happy to have you here. We're glad you had lunch. Good job. All right. What? Yeah. What about the wind? Which direction is that going? North 20 degrees east. Okay, so I've got north 20 degrees east. Why did I draw this vector so much shorter? Because it's 60. The other one's 450. See that? So can somebody tell me the angle formed here? Yep, 70 degrees. Well, it's north 20 degrees east. So 20 subtracted from 90 is 70. Yeah. Yep. Yep. Okay. Can somebody tell me how to figure out A? Well, I'm sorry. I should. I switched them around. Sorry about that. How do I figure out A? Yep. 60 times the cosine of 70 degrees. How do I figure out B? Yep. 60 sine of 70. So we take this 60 cosine of 70, and I get 20.52. And then 60 times the sine of 70, and I get 5638. So I'm going to write that down over here. So I can write, so express the velocity of the wind as a vector in component form. Can somebody tell me what I got there again? 20.52. So we've already done problems like that before, right? So C and D are actually easier than A and B. If you knew A and B, then C and D are easy. Let's think about what C is asking. It says find the true velocity of the jet. We all said that the wind was going to help the plane a little bit. You guys all agree it's probably traveling faster than 450? Here's how we figure out how fast it's actually traveling. We look at the two vectors that we have in this situation. I'm going to draw one in blue. I'm going to draw one in green. There's the plane vector. Here's the wind vector. I take the plane vector and I simply, hey, don't do that. And I simply add it on to the wind vector. Remember when we did vector addition? So that means that this, the sum of it, is what happens when you put the two together. That is the new position. So would you... yeah, so the blue has a length of 450, but the key is that we want to determine the length of this. You guys all agree that the length of that new vector is greater than 450? Yeah, exactly. So what we're going to do is we're going to add the vectors together. So adding vectors together is super easy. You guys all know how to do this. The true velocity of the jet, we're going to write it in vector form. Velocity can be expressed as a vector because it has magnitude and direction. So I add these together, 20.52 and 443.16. Looks like I get 463.68. And then I take 5638 and add it to 78.14, 134.52. The final question is find the true speed and direction of the jet. The truth is that speed is equal to the absolute value of velocity. Velocity can be positive, velocity can be negative. If we want to find the absolute value of velocity, that means we're finding the absolute value of the vector, 463.68, comma 134.52. Does anybody remember the formula that you used to find the absolute value or the magnitude of? Very good. Square root of a squared plus b squared. And so I'm going to take a squared plus b squared and take the square root of it. Just use the Pythagorean theorem. Square root of 463.68 squared plus 134.52 squared, parentheses, enter, and I get 482.80. So the true speed is 482.8 miles an hour. Look at my drawing. We were originally headed at north 80 degrees to the east. But has our direction changed a little bit? It sure has. How do we calculate direction when we're given a vector? It's a formula. You all know it. What's the formula? You said square root of a squared plus b squared. That's how we figure out the magnitude. But what formula do we use for direction? Hint, it involves theta. Hint, it involves tangent. Hint, it involves b. Very good. Tangent of theta is equal to b divided by a. So I take b, which is 132 or 134.52, and I divide that by 463.68, and I get that. What do I do with that? Tangent inverse, 16.18 degrees. So that means that if I go back to my drawing, that this angle here instead of 10 is 16.18 degrees. So if you were going to express the answer as a direction, north, east, how would you calculate the direction? What would I do with this 16.18? Subtract it from 90, and I get 73.82 degrees. That's the true direction. Do you think if you're an air traffic controller, it would be important to know the true direction of the plane and the true speed of the plane? Would that affect the things that you would fly into or the time of your arrival? Yeah. Important stuff. Congratulations. You are done with chapter 7. The most challenging chapter of the whole book. You have your study guide. We have talked about our plan, right? These are the days of school. Should we just cross off Thursday? It's basically over. So you're going to have Friday here, okay? Owatna. And we have a track meeting in Old Town. I got to leave early. But next week, so you got tomorrow you're going to have a work day. And then Monday and Tuesday, you have time to work on your study guide. Homework is due on Monday if you're here. If you're gone on Monday for NHS Field Day, then homework would be due on Tuesday. Test is on Wednesday. No. My goal is to get that done before tomorrow. Yes. 5. I have study guides. Did people get study guides? Okay, I'll hand them out. Question?